Ok, buenas tardes, noches, buenos días a todos. Vamos a empezar nuestro evento de Abril del BolivianJug. Hoy tenemos un gran invitado. Y queremos comentarles que la charla de hoy pues es de Helidon, todo lo que tú necesitas para tu microservice. Tenemos como invitado a Dmitry, Alexandrov. Es un software developer que trabaja en Oracle, Java Champion, y pues él es el quien nos va a estar ayudando con la charla. Hoy vamos a tener que switchar a inglés. Julio va a ser el host en esta oportunidad, Julio Rocha, que es nuestro lead en el BolivianJug, y vamos a empezar a interactuar con él en el evento, ¿no? Recordarles que pueden hacer sus preguntas en el chat de YouTube, y al final del evento vamos a tener el sorteo de una licencia de IntelliJ, ¿no? Pues nada, empezamos. Julio, te dejo.
Okay, thanks. Let's switch to English. Good morning, good afternoon, good evening to everyone. Welcome to our event of Helidon, all you need for your microservices. Today, we have the pleasure of hearing from our speaker, Dmitry Alexandrov. This event aims to introduce Helidon platform and how it can be used for developing microservices. Dmitry Alexandrov is a software developer at Oracle, Java Champion, and our expert speaker for today. He currently works on Proyecto Helidon, and is a true believer in open source. Hello, Dimitri. How are you today?
Hello, buenas tardes. This is right? Did I say it right?
Great. Yes, amazing.
Yes, it's really great pleasure and honor to be here with you. So I know it's like around noon time there in Bolivia, and I'm calling you from Bulgaria. So it's on the other side of the world, I would say so. It's Eastern Europe, so near the Black Sea and Mediterranean Sea, I would say. So really amazing to be here, no matter the distance.
Great, amazing to have you here explain us about Helidon and how we can program microservice with that framework.
Okay, so let's start. So once again, thank you for the introduction. Once again, it's a great honor and pleasure to be here with you. Yes, again, I'm going to do I would say an introduction talk about Helidon, but I will still dive a little bit more into details and what's new actually. It's not only about how to program, but why are we an interesting choice for you? What are the main goals and purposes? And we'll look a little bit in the future as well. So when we have questions, I guess the moderators may interrupt me. I think well, it's going to be fun, I guess. I really hope so. So once again, I work for Oracle, so that's why I have to show you this slide. Whenever you have something to do with this product, just check all the legal stuff. But once again, it's not much in respect of this special presentation, because the product I'm going to talk about actually open source, but a little bit later about it. So nice to meet you. My name is Dimitri. I'm in Sofia. I'm writing code for Oracle, so I'm part of the Helidon team, and it's very nice actually to be presenting about our own product to you. So, and a special greetings from Bulgarian Java User Group. So you have a wonderful mascot. So this is how Duke looks for Bulgarian Java User Group. So special greetings for all Bolivian friends from the other side of the world, from the Bulgarian Java User Group. So really pleasure for us. So let us directly dive into the ideas of what we do. So the most common task of modern development today is we need to create a microservice. Why would you say? Because yes, monolithic architecture is no more like mostly doing the stuff we need. So most of the cases we really need to divide our system in smaller modules, which are called microservices. And by following this paradigm, we create really big scalable systems, which run either on bare metal or the virtualized on containers and clouds. So this is the demand of today. And the most typical application nowadays looks like this. So you have some kind of a client, either web or mobile. So it has a web app which runs in the browser, and then it connects to our microservices, which most probably run somewhere in the clouds. So that can be Kubernetes, that can be bare metal, that can be Verizon. I'm going to talk about it later. So yes, and inside of this environment, microservices usually talk to each other using various technologies. And technically, this is so each of them is like a microservice. So and of course, now it is important that microservices run in the clouds, because once again, this is considered as the most effective way of hosting these services, and it provides you really great scalability. That means that your software is now can scale like unlimitedly in the clouds. So, and most bigger enterprises provide these services, either Amazon, either Azure, Oracle Cloud, and Google Platform, or just on premise. Yes, you can run your microservices everywhere. So, main idea is, how will you actually create your microservice? How will you write your microservice? And most of you will say, of course, Spring Boot. Yeah, typically. Yes, Spring Boot has taken a really, really big part of the market because it's vast. Anyway, today we're going to talk about other way of doing stuff, and which I prefer, and which I call the standard way of doing stuff. And maybe you have seen this sign. This is M, and this stands for MicroProfile. So MicroProfile is an initiative by many vendors, not only one vendor, to create an open source community specification, especially for microservices. So that means that several participants, like you can see here, Oracle, IBM, Red Hat, Payara, Dimitry, even Microsoft, has set together on one table and say, okay, we want to create microservices and we want to create this in a standard way. And as they set together, they have established a set of specifications which are specially designed for microservices. So these specifications are just documents and set of TCKs. That means that every vendor, should it be Oracle, should it be Microsoft, should it be Red Hat, should it be Komuzi, I really can't spell it, but I really like the name. Should it be Payara, they just create their own product which should implement these specifications. And these specifications are specially designed to work in microservices world. And microservices world is a typical example. If you take a look at the computer science question, is a typical example of distributed systems. That means that each component can fail. So we need to be able to check its health, to make fault tolerant services, like it's written here. That's why I have specification fault tolerance. That's why you have the specification of health checks. So we need to monitor and trace the activity of each service, because one business call can contain multiple microservices calls. So I have tracing specification. That's why I have metric specification to read the telemetry of the services, and so on and so on. For security, you have job propagation. And of course, most of the services right now run on, so provide that data and consume the data in terms of JSON objects. So we have the specifications like JSON-P and JSON-B, which actually parse and they're marginal and marginal objects for us. Yep, and of course, it's not only the code that needs to be portable, it's also the configuration. As I say portable, that means that whenever you have your software written with the respect of the specification, you can easily take it from one vendor and put it to another vendor, and you won't need to rewrite anything. This is good. For example, if you take Spring and you want to use it on some Red Hat software, well, you just have to rewrite it. In terms of MicroProfile, you don't do this. So, and of course, it comes to the question actually how to implement a microservice using the standard. And here comes the Helidon to the game. So Helidon is a Java framework for developer microservices. All the information is available under helidon.io. It is a server, but it's not a servlet. So servlet container. So that means that we are not full EE, Java as EE, so enterprise Java. As I say EE, most of the people treat this particular slide as something with Java or Jakarta EE specifications. No, it's not. MicroProfile has some common specifications with Jakarta EE, but they're just subset. So, and it's specially designed to work with microservices world. That means that there is no much, I would say, it's not something heavy and big that we used to think about Jakarta or Java EE. So that means that Helidon is specially designed to work in this environment. And as I said in the beginning, what is cool about Helidon is that it's available under Apache 2.0 license, which actually means that well, it's completely open source. It's available on the GitHub, and everybody is free to contribute. So yes, it's technically led by Oracle and it's written by Oracle guys. I'm part of them. But everybody is able to contribute, to submit PRs, to review, to comment, to propose new stuff, and so on and so on. So this is about Helidon. So let's actually have a look at this architecture to better understand what Helidon does for us. As you see underneath, we have Netty. Netty is considered currently as the most performant, Java network framework. So that means that we take this Netty as asynchronous, powerful, engine to serve our communications via network, and we wrap it with so-called Helidon Reactive, or we used to call it Helidon SE. This is a set of libraries to actually implement those specifications, but in a reactive way. So this is like a wrapper on a Netty, providing class exactly a set of libraries to work with microservices. But as I told you, so we are supporting MicroProfile. That means that from the top, actually, the best actually and the most powerful way to create portable microservices is getting to use the Helidon MP, which stays on top and actually wraps the everything which is underneath, and provides us an implementation of this microprofile specifications. So actually, interestingly, Helidon is technically currently 2 products in one. So that means that you can write your microservices using MP notation, which is a declarative style. So declarative style means that you have a bunch of annotations, just annotate your class, your pojo, and suddenly a lot of magic happens underneath, and it automatically becomes an endpoint. It automatically is started for you, managed for you, etc., etc. Or you can choose the SE way. The SE way is technically to use this set of libraries to create your microservices, and it is pure Java. And we will come back a little bit later to it. So now let's talk about the Helidon MP, which is actually will solve 99% of your demands. So once again, MP stands for MicroProfile, so we implement the specifications. So technically, we implement even not only this specification, but even more. So that means that whenever you actually take Helidon MP, you receive not only implementation of specifications by MicroProfile, but you get even more. So you also get some persistence, you also get transactions, you also get WebSocket because it's necessary. But more than that, MicroProfile is also about not only the core specification, that so-called standalone specification, which are not part of this 13 specifications I showed you, but there are additional specifications which are also hosted under this foundation, but not part of it yet. So for example, we have MicroProfile, GraphQL. So we support GraphQL in a standard way, reactive streams and reactive messaging, and LRA, which stands for long running action, which is MicroProfile's implementation of Saga pattern. So again, we also support CORS and gRPC, of course, but that means that MP provides you a really big set of options for you to run your software, to create microservices. And it's good, well, it's good because it's really, really wonderful that it provides not only a way to implement your services, but 3 ways to package the deliverables. Deliverables means the artifact that you produce. And there are 3 ways of doing it. So from the very beginning, Helidon is modular. So it supports Java modularity as starting from Java 10 world. So that means that you create your application in modules too. That means that you can create a so-called custom image of a JVM with your only modules and just throw away everything you don't need. As you see, even the result, the startup time is really, really smaller, and the disk usage is smaller, and the memory footprint is smaller. That means that you, well, simply the code is, by the way, it's more secure, because if you just throw away the code, which will not run, so you simply won't get any security issues with the code which does not exist. And of course, you can also package into Graph your native image. That means that you can compile your code to native executable and run it, and there the footprint becomes even smaller. So as I say cloud, so I say so many times, microservices and cloud, what does that actually mean for us? So that means that out of the box, once again, we implement these specifications. So one of them, of course, is the metrics. That means that whenever you start your application, Helidon application, automatically you get an endpoint which provides you all the telemetry and monitoring information and a set of counter gauges and meters that produce telemetry data about your service. So it's usually done in Prometheus format, delivered in Prometheus format. That means that you can submit this data to, for example, Grafana to visualize it, and that means that you have all the means to monitor your microservice. I will show it in the demo a little bit later. The same is for tracing. Once again, tracing is essential because one microservice, one business call may contain many microservice calls, and we should be able to see actually how many steps usually one business call make, and that's why we can trace each call. And for this, you have tracing, and you can easily get this information. It's automatically delivered to you in Zipkin or Jaeger system. Once again, automatically you get it out of the box. The same is for tolerance. So as you see, microservices can fail independently, like every distributed system. So you have for each set of means to tolerate this. You get fault tolerance, you have timeouts, retries, different circuit breakers, bulkheads. So I won't get too much into details here because it's a separate vast topic how to handle it. But once again, out of the box, you have it, which is awesome. The same as I said for configuration. So as we support MicroProfile, that means that all the configuration is available for us under this MicroProfile config properties file. And like every standard implementation, you just not get just the code from one vendor and put it to another vendor. You also get the config. So get this MicroProfile config properties, and it will start working out of the box, which is awesome because once again, the portability is really, really essential part here. So of course, if you want to, if you need to document your endpoint, so you use OpenAPI as a standard. So in Spring World, it's mostly known as Swagger, but like extension to this is the OpenAPI. So you get automatically a so-called OpenAPI endpoint, which it's automatically provided to you, and you will know about your microservice, all the information. You can either document it or generate clients to your Open API document. And by the way, by Open API document, you can also generate the full server out of it. So it's available to you. Of course, we not only deliver data and produce data, but we also consume data. For this, you have MicroProfile REST client, which is a declarative style of client. So you just create an interface and it will do automatically for you. And we're now getting to actually try it. But what is good about Helidon itself, that we are actually best in class, I would say. Best in class means that we support GraalVM out of the box, and this GraalVM also works with full CDI implementation. CDI, which is actually provided by Welt. CDI, you know, it's a context dependency injection engine, and it's part of MicroProfile. And I can say that we are probably the only vendor who actually provides full support of CDI inside of Java and inside of GraalVM, which is really awesome. That means that just to mention, so if you have standard CDI extensions taken from another vendors, you simply drop it into Helidon and they will work because it's standard. There was one situation that we needed to use Neo4j, for example, in a database, and it had a CDI extension written by Red Hat, and it worked in Red Hat environments. But since it's a standard, we simply dropped this extension to our code, and it started working for us. This is the standard extension mechanism for Helidon itself. Once again, this makes it quite awesome because actually it's well, I would say opens you a big world of extensions that are done by some other vendors and they're still usable inside of Helidon. So nice, but let's dive into some code actually. So how would you start using Helidon? How would you create your first microservice? And we're happy that beginning from version 3, we already have our so-called project starter available on the website. There you can go and just simply generate your first microservice or make it custom or quick start. You can do the same with so-called Helidon CLI. It will be available like next days in Homebrew or SDK Man. So currently you can install it just from our website. And by the way, it's interesting because this application is actually written in Java and packaged as a distributable executable for 3 platforms: Windows, Linux, and Mac OS. So it's written in Java, but it's still an executable, so it's small and it allows you to create your project. But not only, and I will show you later. So by the way, just to let you know, so most of these things that I'm going to show you today are available as labs. So just go to Oracle Live Labs, just type into Google, go there and search for Helidon, and you will see a lot of labs which you can try. So let's actually demo it. By the way, so you have the same demo actually in Live Labs and OTube. So the same thing I'm doing, you can just watch a video or play with it directly using this Live Labs. So as I told you, yes, as I told you, you can just go to Helidon.io. So I'll go to Helidon.io, and here you can see that there is a starter page. By the way, here you can see you can download, for example, the CLI to use it, and yeah. So we'll just use the starter, and we'll select our flavor. So in this way, it will be the MP, and I'm just going to click next. And you see it allows you different possibilities. So first of all is like a quick start. We're going to use this today, but if you don't want, you can use custom application where you can serve, you can choose what will be your media support. Should we support multi-part, for example? Should we secure our application with, for example, Google login? Should we actually use a database? And if we use database, what is the provider that we want to use? What is the database we want to use? So it's like a magic wizard tool when you detail about what are the components you need. Here, for example, we want to monitor our system with MicroProfile, all micrometers. We need to have health check. We need to have tracing support, for example, to be Jaeger. So you fully customize your application. Should we have a Docker image for different builds, Kubernetes support, and yes, and it will generate everything for you. So wonderful. In this case, I will just reset and create a quick start. So quick start is enough to demonstrate what is the project. So I simply download it, as easy as that. Then I go to console and unzip my project, and I open it in my favorite IDE, in my project. So give me a second. It should, yeah, it's doing something, but I will just put it here. Yep, here it is. So what it has generated for us. So it has generated a small hello world application. In our case, it's greeting application. So it will greet you. As you see, it generated not only the application, but the README files, actually what you can do with it. And let's have a look. How does this code look for us? So if we go to the endpoint itself, we will see that as we use MP, we use the declarative way of creating microservices. So we'll just say under this path, and there is code being request code being like this. It makes several functions for us. For example, if we receive a get standard get, it will produce a message for us. If we need, for example, to add a name, it will produce another message for us. And here with this bunch of annotations, we also say that, for example, it will produce an open API document for us. And we document this endpoint saying that the request should be like this. The content should be application Java. So this could be the schema. These are the typical responses. Like, for example, what is the normal response with this code? What is the missing greeting response under this code? And as easy as that. We also have some provider or message. You see, we use all this inject. That means that we have CDI to care for the dependency injection, so it's in version of control. We read the config properties in a standard way, as I said. For example, here we have some configs, some properties which are available to you. So, for example, we need an application greeting method. So it's available here. And so how you can run it, so you just do Maven. We use Maven as our package manager, so Maven package. So we see it will build it for us. It will also run some tests. Helidon provides a good testing framework. That means that you can easily test your microservices with certain annotations. And yes, as easy as that. And then we use just Java -jar. I have the shortcut of JJ target, and quick was my project. Here's the name, and it simply starts very fast. And now we can curl we can curl our endpoint. So it's going to be, I think, 88, and I'll call greet, for example. Now we have hello world. Lovely. Out of the box, which is good. So as response out of the box, we can read our health information. Health information as a JSON. So it's going to be JQ, so I'm going to parse it. So we see that the status is up and everything is running. So all the checks are done. And we can also read metrics information. Metrics. It will provide us in a I would call it in a Prometheus format. What is the CPU usage? What is the memory usage? What are the endpoints, the end services, and so on and so on? It can be easily visualized with Grafana. So once again, setup is a little bit long, so it won't take too much time to do this. So I'll just say that it provided. So, and of course, we have also this Open API endpoint, which provides us a document describing all of our endpoints, what they do, what are the responses, and so on and so on. So that means that we are out of the box ready, just with few annotation to start the project. As I mentioned, we have our CLI. So now we use this Maven project. If we, for example, use this Helidon, which is the CLI dev mode, so what it will do, it will monitor all the changes that we do in our code, build and rebuild the application for us, and automatically track our changes. So the development can be very easy. For example, if we say hola, like hello, you will see that it will detect the changes. Wait a second. Where is it? Yeah, MicroProfile config. Yeah, it will automatically detect the changes and rebuild and reload for us. And now if we do curl with greet, so let's do it like this. So the message will be Hola Bolivia. I hope you can read it. So it automatically tracks and changes everything for us, and this will help you, nevertheless, the environment to develop microservices in a nice way. So I will just close this one, and as can you have this project starter, so you can easily start creating your microservices with Helidon. Nice. But we have heard in the beginning about this Helidon SE. Actually, let's explore a little bit more, because it is so cool that we actually don't need to hide it, and we can expose it to you as well. So that means that MP follows declarative way, as I showed you. So Helidon SE follows the pure Java way. There is no magic there. There's only one annotation, which is override, which is used. Other is pure functional way of developing your code, and not only function, but reactive. So it's actually situated here. So we just throw away all the magic that MicroProfile does for us. And this way, we receive the very same functionality, even a little bit more, but with I would call even less memory footprint, disk usage, etc., because there are no standard libraries that we use, and we have to implement. We just take the core, the very best core, and I'm sorry, I have some allergic reaction. So I think that you're approaching winter and we are approaching summer, so that's why everything is blooming and my nose is a little bit allergic. So sorry for that. Anyway, back to code. So you just remove all the magic from there, and you receive a very, very fast framework. And this fast framework is actually why. So Helidon has I would say an approach to use as less external libraries as possible. So we make everything technically ours from work inside, so the less dependencies possible. So, and actually we have our own Reactive Engine. So for you who don't know what Reactive is, there is this called Reactive Manifesto. You can read it. As the main idea of a reactive application is to be message-driven, resilient, responsive, and elastic. So, and this is achieved mostly by following the same paradigm. So if you want to learn more about what is reactive, I just highly encourage you to Google any talk by my good friend Venkat Subrahmanyam, just reactive programming, Venkat Subrahmanyam, and it will give you a wonderful explanation what reactive programming is. But once again, the main idea is that you separate your program into three flows. So the first flow is the data, which the second is the completeness of this data. It means that either the data is still running or it should be complete. And if some error has occurred, it's an error channel, I would say, error flow. So we have to gracefully follow it. So the data is coming to you and we don't block on it. another way to control it with a complete channel. And if an exception occurs, so we can gracefully handle it on the data which is coming. So from Java 9, there's a special API available to us, which is called Flow API, which actually consists of 4 interfaces with publisher, subscriber. A link between them is a subscription, and in between publisher and subscriber, there can be a processor of the data, which sits between and which actually transforms this data. So it's a combination of iterator and parts. So I just say to you, you don't know because it's low level, but we are based on this, which makes us quite unique because other frameworks are still coming to use this API, although it's available from Java 9, but we already use them in production. And what we actually have. So we have created our own reactive engine. We don't use any other side projects, like for example, Project Reactor or Mutiny or Akka or something. We have our own reactive engine, which is developed by Dave Karnak himself, the father of Reactive. And the idea is that we have our own set of reactive operators, which is, well, if you have ever worked with Flux, so you have this Flux and mono. In our case, it's multi and single. So multi, that means you have some data, multi, a stream of data, which you can asynchronously, reactively process by actually adding reactive operator. Here, for example, we add an operator of limit, then we do map, and then we just sum this up. This will be done asynchronously and reactively for us. You can do the same for single value as well. So Helidon has a rich set of reactive operators, maybe not that rich as Project Reactive, but it's enough because there, for example, I personally find it as too much. But here we have a very good set of operators, and they're quite fast. Every time I say fast, we're sometimes twice as fast as our competitors, like you can see the graphs. So, and as a result, when you have your own reactive engine, you can create a reactive web server for it. And this is what we did in Helidon SE. So that means that we create a server which is completely reactive for us. Yes, and you just start it out in a reactive way. So let's go back to the demo again. What is it? Oh, it's the IntelliJ which is started. So this time I will create a project using Helidon init command, and I will create a flavor of quick start with Helidon SE. And yep, should we start development loop? No. As easy as that. So now we create the project using our CLI. We'll also open idea of quick start. And what we will see, interestingly, that it starts as the new idea and it starts in a separate window. I don't like it very much, but anyway, it does start. So what we can see here is that we received the very, very same functionality, the very same greet service, but now it is done in Helidon SE way. So for example, there's only, so what do? We go to main method because it's pure Java. There's no magic. And in this main method, we just simply create a server, build a server, create a config, and then we start the server. You see, as we start, it returns a single. That means that it gives a kind of a promise that the server is started, and whenever it's done, we can do something with it. For example, when the server is started, we say then accept. That means that whenever it's done, the server is running, and you can shut it down when it's done. But if something goes wrong, remember those channels, exceptionally, they say, okay, something went wrong, and that's it. It's reactive. So here, for example, we register some, health endpoints and metrics endpoint. As you see, we need to do this manually here. And for example, we register some service. If we go to the service itself is pure Java. So we only say that, for example, for this handler, use this method. And this method is a typical functional interface receiving request and response. As easy as that. So we just get the response, do something, a request, do something, and return a response. Very, very easy. And you have a rich set of reactive operators. You can do everything reactively here. So by the way, if I'm services, yes, for example, what is cool about the Helidon support. So it should arise here that we have Helidon service. Yes, you see this mark. So that means that IntelliJ IDEA is actually aware that we have services, and it provides us, a good debugging as well. But let's actually go there and start the service. So what we do, we just start it out directly in the ED because it's just a main file. And you see how fast it is. So fractions of a second, and it's running for you. And what is cool, once again, if we do curl for the same endpoints, like for example health, it's already available to us, even extended, I would say. Metrics. Oops, just a second. Metrics. We receive you the same metrics. Yep, but by the way, if it does the same greet message, yes, it does actually. So hello world. If we do, oops, if we do curl with, yes, it will say hello. Once again, this is absolutely the same thing, but absolutely reactive way of doing stuff. So you're able to generate it and to have it out of the box, and it works absolutely the same way, directly from the IDE. Nice, but there's some buts there. So let me just close this this IntelliJ to be completely sure that we don't have anything. There's some buts, but before getting to the buts, so I just say that there is also reactive messaging. So if you are heavily loaded with messaging, ASIC connectors follow the MicroProfile specification, but they do in this no magic philosophy in a reactive way. So that means that you're able to process huge amounts of data in a reactive way. And you have connectors to Kafka, GMS, AQ, and even our socket soon. That means that reactive messaging is there for you too. There is one thing. If you are reactive, you always to be reactive. You can't block in the middle. Otherwise, you will lose this superpower of asynchronous development. So here, for example, we have our own special DB client, which allows us to work with JDBC driver, which actually blocking, but in an unblocking fashion. So it automatically starts the driver in a separate executor, and it starts to talk to it asynchronously, allowing us to do asynchronous call. And all the synchronous calls will be done in a separate executor. Thus, we will do everything in a reactive way. So you just set it up, and you're able to execute queries as the way you were used to. The same is for web client. That means if you consume services from other clients, you were able to do this completely asynchronous for you. So you will always ask me, why would you need Helidon MP and SE? And here I always show these two slides. So MP is like an airliner. So that means that it's a comfortable way of doing stuff. It really does the most effective work for you in terms of how much you code and how fast you get the result. But if you need special performance operations, like really special performance, it's not that convenient, it's not that comfortable, but you receive massive power, and then you use Helidon SE. So just to mention a few other technologies, we have a few time left. So Helidon comes with two sister products, call it, which allows you a massive and very cool integration with it. So we know that Helidon supports persistence, and it can work with all databases using all GPU providers like Hibernate and Eclipse Link. But if we take a look at the Helidon and the product called Helidon Coherence CE, we can receive really awesome results. So coherence is, if they call it, the world's first in-memory data grid. So it's a key value store which is highly scalable, and it allows us to run a persistent key value storage and to scale it horizontally and vertically in our cloud environments, as it does supports Kubernetes, and it has all the cloud native stuff as monitor with Prometheus, Grafana, and Jaeger, and all that stuff. So, and the coolest part is that there is a community edition since 2020, though. That means that you can use it for free. So once again, it's not just a cache, it's a KV store, which actually can portion data across multiple clusters and members and scale the system as we care. So that means that whenever you need to store some data across multiple clouds or multiple deployments, coherence is there for you. So I won't dive into it. I just want to, I'll give the slides after this talk to you, so you can easily play with it. There are demos and videos with demos there, so you can enjoy it. The same is about cloud native deployment. What is nice is that, so we'll discuss that, what is the preferred way of doing it. So we created a microservice, but it has to be deployed in the clouds. So how will you do this? So previously, we know that we had to deploy it on bare metal. Well, then come the virtual machines that we are able to, to deploy it in so-called virtual machines, which are actually running on this bare metal, but allows us to better structure the resources that we have. Now, the most typical way is to containerize our application using Docker. So each container is virtually separated from the other. And there's a Docker that runs and manages all that stuff. And if you have a lot of these images, we come to Kubernetes. So Kubernetes is a way to manage all these Docker images and to actually create multiple deployments containing multiple images with all the networking and service balancing there, all provided by you out of the box. And here we take one step further. So it's not only Kubernetes, but if we want to deploy our application in the cloud, we want to wire up not only Kubernetes itself, but wire up a lot of other services together. And here comes the Verrazano. Verrazano allows us to run many other applications. Should it be microservices with Helidon? Should it be traditional applications like, for example, WebSphere? Should it be other stuff like something written in Python? And it will run it in container in Kubernetes, and additionally wire up all the Istio stuff, which is service mesh. It will automatically provide you Grafana to monitor your services. It will automatically provide you Jaeger for tracing the services, Keycloak for managing the credentials, etc., etc. So it puts all those things together and allows you easy management of your software. So it's actually named under the Verrazano bridge, which connects two worlds of microservices with the deployments that we do. And what it actually does for us in this case, that means that whenever you have Helidon, it will create just two descriptor files for us, which will be a component descriptor and application configuration, and it will create a so-called automatic deployment. That means it will run your service and it will automatically wire it up with services like Grafana, Prometheus, Kibana, and Elasticsearch. As Helidon has its own personal workload, that means the first-class citizen, you don't have to do this yourself, or you don't have even to hire a DevOps. So you just say, okay, this is our application, put it into Verrazano, and Verrazano will do everything for you. It will automatically deploy it. It will ensure the observability, it will ensure the security, and it will all do in this stack of stuff that you say. You only need to provide two deployment descriptors. As easy as that. So by two files, it actually creates everything for you in your app space and wires it up to the monitoring services like Grafana, Prometheus, or Elasticsearch for search. So you may actually try it once again. I won't dive much into it here. There is a demo with it, so just go and play with it. It's really awesome. But as I told you, let's talk about the future a little bit. So reactive is considered hard. Yes, it's hard to learn reactive. So it's nice, it's powerful. It's currently the most powerful, the most, I would say, performant way of creating a microservices, but it turns out it's really hard to maintain, debug. And here we say that finally there is a solution. And this solution comes from so-called Project Loom. What is that actually there? So earlier last year, so in April, actually a year ago, well, right exactly an April ago, a JET 425 has arrived, which introduces so-called virtual threads. This virtual thread arises from the Project Loom, which was an experimental project. And this project utilizes the idea of light threads, which are kind of a cheap resource for us. We all know that threads are expensive. That means that currently in JVM, they were implemented as wrappers over so-called system threads. And every time we get a new thread for doing something, it's expensive of descriptors, it's expensive of memory, and all the context switch between threads was expensive. So that means that they created a special, virtual threads, which by API is absolutely the same. But the JVM actually cares for them, and it actually automatically distributed the real threads to these virtual threads, they say. So that means that when a virtual thread blocks in some way, it simply does not block the entire processor itself, but it's get unmounted by the JVM, and it's given to another, the character is given to another resource to do some work. Whenever, for example, we're waiting for some IO operation to have a read from disk or from database, whenever the thread is back alive, the virtual thread, so the scheduler actually sees that, okay, we have a thread with back, so we have to ensure him a resource or the real thread. And they have actually implemented it over several years, and it's available to us. So currently, the API is that we have a new executor, which actually allows us to use threads. Funny thing is that in the beginning, like even before this project got to like real shape, Helidon already supported virtual threads, allowing us to run the code in the virtual threads executor, and it was actually an experimental way to work with them, and it provided really massive paradigm, not paradigm shift, but performance shift. Once again, that means that you are able to write non-blocking applications by speed by using the blocking paradigm. Yep, and that was really, really awesome. So currently, it's already available since JDK 19. You can actually start using it. But Helidon, we took one step further, and we have introduced our own brand new engine, which we called Helidon Nemo. So it's the world's first framework which is completely based on virtual threads. So it's built from ground up together with Java team, and it technically replaces the Netty, which I showed you in this graph underneath. That means that as you see in this picture, we simply replace all this reactive stuff with Nemo, with fully blocking way of writing code, which does performance, which is really close to the real one. So that means that it absolutely implements from the very beginning this protocols of HTTP, HTTP2, gRPC, WebSocket, TLS, and TLS support, and everything is implemented in a blocking fashion. It also supports access log cores, all the static maintain, all this observability features out of the box. And since it uses new features of Java, beginning of 6 to 17, like virtual threads, like enhanced switch, like seal class, system logger, it performs really massive performance boost. Why would you say we need that? So it's actually like this. So if you need to create asynchronous call, you usually have a lot of code, which is very hard to read. And on your right side, you see the same code actually, which is called in blocking fashion, and it's available to us, and you can achieve the same or near the same performance. As I say, the same or near the same performance. Actually, at some moment we even do it faster than netting. And if we put it to Helidon MP, which runs on Nemo, you have a magnitude of performance boost. That means that you literally have to do nothing, just use the newest technology, newest framework, which will come to you very soon, and you will have a massive performance boost. So once again, you have to be clear that the nature of microservices is that you have a lot of short-running tasks, which actually, like block the thread for some time. But if, for example, there is I/O operation, it can be long for a longer time. But the idea is that all those blocks which arise during the microservice use are very nice, suitable for virtual threads. They are by the nature nice. A nice example of using virtual threads. If you, for example, do some Bitcoin mining on your thread, of course you will use all the threads and virtual threads will be usable. But especially for microservices operations, it is really, really the best choice. And once again, the performance is really good. So currently, you see, we are writing some of the components which were previously reactive. We make them blocking again, thus allowing them to use all the benefits of virtual threads. And actually, funny thing is that you get reactive performance with blocking code, and it has been open sourced with Helidon 4, so you can actually play with it. So I can even show you a small demo actually what is actually happening and why it is important to have it. So we have 2 minutes, but I would definitely like to show you this demo. So let's it's here. I will put it put it here. So what is the problem that we're actually solving? So I hope you don't mind. It will take us 5 minutes, so a little bit more than an hour, but still I would really like to show it. So imagine you have server which do quick response and fast response. So here it is as a resource. So the quick response responds immediately, and the long response actually just sleeps for a certain amount of time. So it blocks the real thread. And the idea is that when we have all the threads blocked, this quick request and response are not able to be actually even reached. So I will show it in the demo. So we need to somehow solve the situation. So there's a lot of waiting time just for the sleeping, and as it's sleeping, it's using nothing. And if we do it in a reactive way, the same way, you will see the difference. But actually, let's run it. So give me a second. So I will start my my special group of terminals, and what we will see. So if we run a no loom server, so that means that there is no loom running, and we start a so-called slow client, which claims for slow endpoint. Where is it? Client slow, and we will start the fast endpoint. Target client quick. That means that, you see, when we use, for example, we use the thread pool of 10. It made 10 requests and it successfully. 10 requests and successfully. That means that we are blocking the thread, and you see the quick response have a lot of errors. That simply cannot reach our endpoint because it is blocked. Okay, nice. If we do the same with reactive, by the way, just to show you once again the no loom, I want to show you the htop. That means that our server is really low utilization. We have the resource, but we can't use the resource because it is blocked. See? Great. Now, if we use the reactive server, target server reactive, you see all of a sudden we have our blocking request with success, but the smaller resources are also starting to respond. That means that we are using non-blocking operation here. So that means that the response is fully utilized. You see, even the processor itself is now fully utilized, which is kind of awesome. Okay, we stop this. You see, reactive is hard. And now I go to the new Helidon Nemo server, which is absolutely the same endpoint, but written with underneath with Nemo. That means that it will use virtual threads out of the box. So I'll just say target and server 4. And what we will have here. So all of a sudden, you see, the very same blocking code, but with Nemo underneath, which uses virtual threads, automatically starts responding the same way as it was with the reactive code. That means that we start utilizing the resources in a much better way, and it's all done by JVM for us, and the all code is written in blocking manner. So you see by own example how actually cool it is. So this is what we are solving right now, and this is why I say Helidon is technically, well, the future actually. And I will just close this one, and I will just go back to the presentation. And now it has been open source with Helidon 4, so its version Alpha 5 is already available in Maven Central, so you can just go and play with it. So as a summary, once again, microservices are the preferred way of doing, is the preferred architecture for doing scalable applications in the cloud. Helidon, as I say, is the Oracle's preferred way of creating microservices, and you know why? Because it's full microprofile compatible, and it also provides you this reactive flavor. It is first for performance. It's first-class citizen in frameworks like Coherence, Verrazano, and has all the integrations with modern services. And as I showed you lately, we're now starting to use virtual threads. That means that you have a huge performance boost just out of the box for you. And you will use the blocking paradigm. So you don't have to learn this very, very, I would say, ugly reactive flavor, but you will have the same performance. So if you want to learn more about Helidon, so we have a lot of social media. So mostly in Twitter, but also have LinkedIn, we also have Mastodon. If you like long articles, go to Medium. If you like watching videos, go to Helidon Project YouTube channel. If you have questions, just put them in our Slack channel. And if you want to contribute, so it's available in GitHub under Helidon IO. Well, it's written in, it's IO. We have our organization, Helidon IO organization. Just go there, take a look at the code, submit your PR, or maybe submit an issue. So with this, I would say muchas gracias to you. Thank you so much. And I really hope that you like this presentation.
Great presentation, Dimitri. I didn't know about Nemo. Looks quite promising.
You see, it's a groundbreaking technology, I would say, definitely. So that means that you have a standard microprofile standard, which runs with virtual threads, and it have a massive performance boost for you.
Yes, looks amazing. I'm gonna have a try with this.
Really
it looks like we have some questions from the public.
Of course.
Okay. Let's start with the first. Do we need to add some special annotations or descriptors when we are using response class in our REST APIs to serialize?
To what? I'm sorry, I did not get this question. Do we need to add special annotations?
Yes, special annotations or descriptors to serialize responses when we are using the response class in our REST APIs.
No, so it's done automatically for you for JSON-B binding or JSON-P. So you just place the object there, and it will automatically marshal it for you. In MP, in SE, it will also do for you if you set it up correctly. Just you need just to add not descriptor, but you need to. But once again, it's a reactive flavor. I really don't like, just don't go there, because Nemo is coming and you will not need it. But yes, it will. But it will be done automatically for you. No special descriptors.
Okay. Which Java versions are supported by Helidon?
So this is a very good question, because Helidon always follows the latest Java version, major Java version. For example, Helidon 2 is using minimum Java 11. Helidon 3 uses minimum Java 17, because it uses a lot of benefits coming with you Java 17. And Helidon 4 will use LTS, which is Java 21, I guess. So because we're using virtual threads there, and we use sealed class, a lot of stuff which came there. So our policy is to use always the latest LTS support of Java. And I know there's a big discussion about this. Is it good or bad? But as we actually force this to our clients, and they migrate, and they say they have a lot of benefits in performance just out of the box. So this is our philosophy.
Great. In your experience, what should we choose Helidon over other frameworks?
So from my experience, Helidon is cool because it's, once again, I would say the only micro framework which is standard, which fully supports MicroProfile. MicroProfile, that means that you can easily migrate to Helidon from other frameworks. Well, it does support native image out of the box there as well. And once again, the sizes of the artifacts are really small, I would say. So, for example, I have, just give me a second. I've done some experiments with Spring Boot, for example. So if I open Spring Boot and take a look at the artifact of very same application, you see it's, for example, it's 29 megs if we do this greeting application. If we go to Helidon, which is generated here, and we go, because you see it uses hollow jar and libraries, but if we take the common count, it's only 14 megabytes. So it's really small. And in you know that in clouds you pay for everything. So that means that the startup time is faster. If you do native image, it'll be also faster. At the size of memory footprint is faster. So in big scales, this will save you a lot of money. Literally.
Yes. Yes. And the last question is, you mentioned 3 types of packaging: native, yes, JLink JVM, and JVM. Which is more stable for production?
So I always prefer to use the Java way, I would say. The Java way means that either jar or JLink custom image, because there you have all the benefits from running your code for a long time. Once again, if you do native image, that means that it does all the optimizations, like, ahead of time. And the JVM, there's no JVM, I would say. So it just cannot be more performant than if it was running on hotspot, for example. So JVM, does a lot of runtime optimizations. So if you make the long-running services, you definitely should choose regular JVM. The startup time is slightly more, but like you have like 60 milliseconds or 70 milliseconds. You won't even feel it. But if you run it on JVM, either on JLink or just jar, it will be much more I can't say stable. They're all stable because it simply works. But it must be much more performant, I would say, in terms of long running. If you require faster startup, for example, you want to use it like behavior, like in Alpha, in Lambdas, in Amazon Lambdas, when you start up, do something and vanish, then you can do native image. By the way, there is one project called Oracle Hospitality. It's everywhere. You know, every hotel, every ship, everything which has to book something has Oracle Hospitality like software, and they use Helidon and they use Reactive Helidon there, and they have compiled their code to really tiny microservices. So they compile them to native image. So each of them is only 10 megabytes of size, and they massively scale. Like for example, we know that today or tomorrow will be a holiday and everybody will book. So we'll just scale massively for every booking, and they start really fast. But when you don't need the resources, they simply get vanished. So once again, it really depends of your nature of your code. But for long running microservices, you need to. I would prefer it to be JVM. For microservices that live for a second, this is also an option. You can just do Graalvm native image. It will simply work.
Great, thank you, Dimitri, for all your answers. Let's continue with you, Omar.
Okay, thank you, Dimitri, thank you, Julio. Ok, vamos a continuar para toda la comunidad del BolivianJug. Como es costumbre, pues vamos a sortear una licencia. Para esto vamos a hacer una pregunta y el primero que responda en el chat de YouTube, pues se gana la licencia. La pregunta es simple. ¿Cuáles son los dos sabores de Helidon que tenemos para usar?
I'm sorry, I do not understand, but
Sorry, Dimitri.
No.
Sorry, Dimitri, we switched to Spanish to raffle off the license of the JetBrains license.
Oh, okay, I see. Yeah, good luck.
Thank you, Dimitri. Ok, ya tenemos, creo que al ganador. Pedimos que nos mande un correo a Gabriel para coordinar el tema de la licencia. Thank you, Dimitri. Thank you, Julio. Amazing talk.
It's been a pleasure, and next time I will learn more Spanish. Like, yes, thank you so much, and it was a pleasure. And well, whenever you have something to ask about Helidon, just tweet me or ask us. So we're always available. We even have our support duty in our team, so we respond very fast. Thank you so much.
Thank you.
Okay, Dimitri. Thank you to everyone, and have a great week, a great day. Bye.
Thank you.
Thank you.
Bye.
Bye.